Now, today we will talk about factoring difference of squares. Now, the main idea here is that a square number is a number that you can take the square root of. So now here we have four examples of what we're going to call a square number or a square expression, because notice that here that 9, we can take the square root of 9, and that's going to be equal to 3. Because we can take the square root of this, then we're going to call that a square number. The same goes for 25. The square root of 25, that's just 5. Can we take the square root of 9x squared? Well, you know that the square root of 9 is 3. And the square cancels out with the square root, so we're going to have 3x. Now the same goes here. If we want to take the square root of 4x squared, we know the square root of 4 is 2. X squared, take the square root of it, it's just 2x. So now, let's look at some examples. So now here's our task. We try to factor the following. Now this is called a difference of square. And when we have a difference of squares, we can factor out that difference of square using the following formula. A squared minus b squared equals a plus b times a minus b. So look at this first expression. Try to see if we can rewrite it as a second exponent. That is there a way for me to rewrite this as of what we have here? A squared minus b squared. Well, let's see. 9x squared, I can rewrite that as 3x all to the second exponent. Now, to double check, 3 to the second, that's 9. X to the second, that's x squared. So we're good with the first expression here. Now let's see, can we do that for the second term here? Well, notice that 1, you can rewrite that as 1 to the second. Now, what's the purpose of this? Why do we decide to rewrite it into this form? Because now that we have it into this form, we can just apply this formula, because we know that a squared minus b squared is equal to a plus b times a minus b. So that says that in our formula, 3x, this is my a, and 1, this is my b. So that says that this expression, you can factor it out as a minus b, so that's 3x plus 1, parenthesis, a minus b, so that's going to be 3x minus 1. So now let's take a look at the second example here. Again, what we want to do first, and try to rewrite it so we can use this formula. So let's see, is there a way for me to rewrite this as something raised to a second exponent minus something else raised to a second exponent as well? Well, let's see. For n squared, I can rewrite all this as 2n to the second exponent. To double check, 2 to the second, that's 4, n to the second, that's n squared. Now 49, I can rewrite that as 7 to the second exponent. Now that we have it into this form, identify what a is, which in this case, your a is 2n, in this case, your b is 7. So now that we have that, all you need to do is just plug it into a formula. So we want to factor this out. This becomes a minus b, which in this case is going to be 2n minus 7, parenthesis, oops, I'm sorry, should be a plus, a minus b, so that's 2n minus 7 now. Now that we have it to this form, we're done factoring. So now let's take a look at the last example here. So notice here in example 3, again, the first thing that you want to do is try to see if you can factor out, or I'm sorry, rewrite this into a squared plus b squared. So let's see. We're going to have this minus something else to the second exponent. A to the second, we can read that as a to the second. And 25b to the second, we can rewrite that as 5b to the second. Let's double check. 5 to the second, that's 25. B to the second, that's b squared. So now that we have to this form, identify what your a is. So in this case, your A is A, and in this case, your B is 5B. So now, if we want to factor it out, we're going to have A plus B, so it's going to be A plus 5B, parenthesis, A minus B, so in this case, it's going to be A minus 5B. And this is how you factor it out if difference was square. So now, here's your entrance ticket. Try to factor the following.